and welcome back to my channel. I am Mr. Sensible, and today we're going to have the benefit of being schooled in physics by Mr. D. Marble. I know you're going to enjoy this. Mr. Marble, the stage is yours.
One of the comments that I always get in these flat earth videos that I'll upload, typically the ones I'll do about the movements of the celestial bodies or gravity, one of the responses I always get from these globe believers, the more triggered ones, is you don't understand physics.
But perhaps that's because you don't understand physics.
And my response is always pretty much the same. I'm like, oh look, another physics expert. Well, here, how about this, genius? Go ahead and explain the physics of liquids or water in large quantities. Now, do they ever do it? No. For some reason or another, globe believers like to tiptoe around that particular aspect of physics. So let's do a quick check on understanding, a real simple rudimentary exercise, and then we're going to look at physics.
Okay, I've got pen and paper ready. Let's go.
Now, what do you see here? A globe. B, a bowling ball. C, a spherical balloon.
D, your head's nearly as big as the planet.
A globe.
Oh, bugger.
Moving on. Now, what is the most prevalent surface color on this globe? A, white. B, green. Or C, blue.
I want to say green. What? White? Blue? Green!
Blue.
Oh,
Very good.
huh?
What does the blue on the globe represent? A, land masses. B, water. C, lava.
I think that the blue represents the angle of attack.
B, water. You would be correct if you guessed B.
Correct if you guessed B. I'm just wondering, on the average intelligence level and level of understanding and knowledge of your regular audience.
Under what state of matter is water classified? A, a solid. B, gas. Or C, a liquid.
Or D, can you give me a hint please, because I'm too dumb to even be allowed near teaspoons.
And if you chose C, you are correct.
And probably smarter than the average flat earther.
Now, let's take a look at the conclusion here. Most of the Earth's surface is covered by liquid. That's what we just established by answering those questions. Still with me?
Yes, I'm managing to keep up, okay?
Good. Now, let's take a quick look at a short video outlining the physics of liquid.
At last, we're actually going to learn something, maybe?
Liquids seek their own level. Let us perform an activity to show that liquids seek their own level. Take a series of interconnected tubes of different shapes as shown here. Pour colored liquid into one of the tubes. Observe that the liquid stands at the same horizontal level in each tube, even though the area of cross-section of each tube is different. We know that the pressure at the top of each tube is equal to the atmospheric pressure. Similarly, the pressure at the bottom of each tube will also be equal. Hence, liquids seek their own level.
My God, really? Really? You think you're teaching anyone anything? You think people are so... Phuket word, please stop chewing that power cable.
Okay, so to go along with that, here's an example. Here's a cross-section side profile of the Panama Canal. Now, what you can see is on the far right side, it shows the Pacific Ocean at sea level.
Are there many oceans that aren't at sea level then?
Which you can see is pretty much flat on the surface. And then what happens is the boats move across Panama through a series of locks, rising and lowering the level of the water, moving across the landmass and then coming out to the other side on the Atlantic Ocean, which is also at sea level.
So that's two oceans that are at sea level.
Now this side profile here shows that, in correlation to what we just saw as the physics of water, that the surface of water is always flat, that water, liquids, seek to find their own level.
Well, that example shows us nothing about the physics of water and has nothing to do with flat Earth or globe Earth for that matter. It just shows that you need locks to raise the level of the water if you're going to try and cross higher land.
Now, you in your own personal experience have never seen water do anything on the surface other than represent a level surface, as if a perfect mirror. Now, if the surface of water were bulging, such an effect wouldn't be possible. This whole mirror thing that we have going on right here, that's not possible if the surface is curving. But then this is where people would make excuses saying that this particular body of water is too small and that there's not enough space to see the curvature.
This particular body of water is too small. There's not enough space to see the curvature. Bugger, caught me. Look, if you could see curvature on that lake, just how big would the Earth be if it's curving visibly just on that little amount? I mean, you could probably walk round it in a day. Twat.
So let's take into consideration what you're seeing here. This is the world's biggest mirror. It's the salt flats in Uyuni, Bolivia. This place is 100 miles across and about 80 miles wide. And after it rains, there's about an inch or two of water and it becomes a perfect mirror, as you can see here. That doesn't happen on a globe.
I just showed you a whole bunch of photos with reflections on curved surfaces. So absolutely you would get a reflection off a globe. Now in this case, in that clip of film, which is a beautiful, beautiful bit of film actually, but in that case, that reflection looks perfect because the sheer size of the Earth, the curve that would be visible and would distort in the reflection is so minute you can't see it, but it's there.
That's entirely too much missing curvature.
No, it isn't. The Earth's circumference approximately 40,000 kilometres. You can see about 4 or 5 kilometres until the Earth is curved away from you, and your field of view will only be a few kilometres. Now if you take that 5 kilometres, then that is about 0.009 degrees of curvature. There's no bloody way you're going to see that. No way at all.
So you know the physics of water. Water seeks to find its level. And that's what the surface of level water looks like. Right there. Perfect mirror. Accumulates and gives off that reflection, indicating that there is no curvature on the surface.
Give it up, Marbles. Try something else.
This is one of my originals from a while back.
And it's just as fail as it ever was.
And this is just to get you thinking about this stuff. The simplicity
Of flat earthers.
of where we are. Whether it's water in a glass,
Fail.
whether it's in a pond,
Fail.
a puddle,
Fail.
in a lake,
Fail.
or on the ocean.
Fail.
The surface is always flat and level. You need to take into consideration the fact that bodies of water only appear to curve in pictures that you will never be able to take for yourself.
Well, unless you can go high enough Perhaps you could get yourself trained as a pilot for one of these. Take this up to 25 kilometers and you're definitely going to see it.
And that's the pictures of the entire globe. Chances are you're never going to go to space and be able to snap that picture. Neither am I.
Yeah. He definitely wants to go, definitely would like to go up there. Primarily he wants to take a photo to see the globe because he thinks you're all lying. Yeah, so will you accept him on your training program? Excellent. Yeah, his name's D Marbles. Oh, they put the bloody phone down on me.
But what we know in our reality is that the surface of water is always level.
I don't think you've got the faintest idea of anything to do with reality. I don't think you've got a bloody clue about reality.
So, I'll admit it that both of these models have their own flaws.
Flaws? Flaws? Flat Earth can't explain anything. It can't explain the movement of the sun, the moon, the stars, can't explain the seasons. It's just, it is a flaw.
But you gotta ask yourself, which one of these matches your experience in reality?
I'm not an arse hat wearing fucktard, so I'm going to go for the globe. I reckon you might go for the other.
What's closer to what you know? Water clinging to the outside exterior of a ball? Or water finding its level? That's all I got for this one.
Marble, I think you need to go back to kindergarten. Start from scratch, see if you can learn something. Then perhaps you won't look like such an idiot posting these videos on YouTube. Well, that's it for today. Thanks ever so much for joining me. If you haven't already, please subscribe using the little ball in the corner, and I'll look forward to seeing you when my next video is out. Stay sensible, guys.
Shut up and sit down.